Prove that this expression here is equivalent to tan theta for all values of alpha. Find the exact value of this expression here. It is given that k is a positive constant. Solve for theta between 0 and 60 degrees, and in terms of k, the equation given here equals k. This expression here equals k. So let's have a look at this then. I've summarized the question here. So let's work through it then. Part 1. Okay, part 1. So prove that this equals tan theta. So let's use the compound angle formula then. So we'll call this the left hand side. So here the left hand side is equal to, well, sine theta, compound angle, sine theta, it's sine cosine minus cosine sine, isn't it? Plus the 3 sine theta, and then it's sine cos for the next one, compound angle, sine theta cos alpha plus cosine theta sine alpha. Oops, sine alpha. There we go. That's a plus there, wasn't it? Okay, so that's the numerator. Now the denominator, and that will equal, and the denominator is cos, isn't it? Cos plus sine when you use the compound angle formula. So it's cos theta cos alpha plus sine theta sine alpha plus 3 cosine theta plus, and then it's cos minus sine. So, oops, we've just used the compound angle formula all the way through to simplify this. And now hopefully some terms will cancel out. So what do we have? Sine theta minus cos theta sine alpha plus cos theta sine alpha. So this one and this one cancel. We've got minus sine theta sine alpha plus sine theta sine alpha. So these two cancel as well. So we're left with then equal to, so here, what have we got then? We've got 2 sine theta cosine alpha plus 3 sine theta. So there's a sine theta common. And then we've got 2 sine theta cos alpha. So that'll be 2 cosine alpha, won't it, in the bracket. Minus, and then we've got plus 3 on top. Underneath, we've got cos theta cos alpha plus another one. And there's a cos theta common, isn't there, throughout? So let's take out the cosine theta as common. And we've got 2 cos alpha together, 2 cos alpha. And then we've got plus a 3 cos theta, so that's plus 3. So now these two cancel, don't they, top and bottom? So sine theta over cosine theta. And that's equal to the tangent of theta, isn't it? So that's what we wanted to show for part 1. Now part 2, now it says find the exact value of this. If you look at it and compare it with what's above, again we'll call this I, capital I, I've already done it here. If we compare it with what's above, this is 150 minus 1. And this is, so theta is 150 here. And alpha is 1 degree. Here, this is part 2, we can see that theta is equal to 150 degrees and alpha is equal to 1 degree. So I is equal to then, so what have we got then? So I, the stuff we had on the left hand side, with those values of alpha and theta, we can see that this is identical to this with the substitution. It's fairly evident that this is true because this, but the numbers are different, aren't they? So this is 4 times. If we take a 4 out, we'll have 4 of these. And if we take a 3 out underneath, that should be a 3. I think I've written the bottom, this should be a 12, shouldn't it? Or something. Let's have a look at the actual paper, see if I've written it incorrectly. So it's 3, 9 and 3. 3, 9 and 3. 3, 9 and 3. So it helps to write out the problem correctly, doesn't it? 9 and 3. So it's 3 times the bottom, isn't it, as you can see when you take a 3 out, and 4 times the top, and you get this term here. So it's equal to 4/3 tan theta. Tan of 150 degrees. Now 150 degrees, we can tap it in the calculator. I've done it here. Times 5, it's root 3 over 3. So, okay, minus root 3 over 3, so it's equal to 4/3 times minus root 3 over 3, which equals minus 4 root 3 over 9. So that's what it equals to then, when we work it out. So that's part 2. Solve this now. Now this is identical to the one, part 3, with theta is 60 and alpha is 15, and we can see that correspondence quite easily. Everything is identical. Theta is 6 theta though. Sorry, 6 theta is instead of theta, and alpha is 15. So part 3. So here, theta is equal to 6 theta, and alpha is equal to 15 degrees. So, tan of 6 theta, which is what we want to work out, is equal to k, isn't it? K degrees. Because theta varies between 0 and 60, 0 and 6 theta, must times it by 6, 60 degrees by 6 is 360 degrees. So that's the range, isn't it, for 6 theta, if the range of theta is 0 to 60, which it is here. So 6 times 6 times 6. So let's solve it then. We got tan 6 theta equals k. Draw a circle, right cast. So tan, k is positive. Sorry, I've got to go back and have one more check for k. And k was a positive constant here. We're told that in the actual question. In terms of k is a positive constant. Yeah, that's fine. So let's go on to the question again now. So tan 6 theta is k. Tan is positive here and here. Draw 2 lines. Mark off alpha, the associated acute angle, and simply write tan alpha is equal to k. So that tells us then that alpha is equal to tan to the minus 1 of k. So 6 theta is going to equal, well, the first solution will be around to here, which is tan to the minus 1 of k, or 6 theta will equal, and we go around right around to here, so it's 180 plus. So we're working in degrees, 180 plus tan to the minus 1 of k. So now we can read off theta is 1/6 tan to the minus 1k, or arctan of k rather, and theta is equal to 180 over 6 is 30 degrees, plus 1/6 tan to the minus 1 of k.